Okay, so before we begin our next lesson, you need to go onto this page and you need to memorize, have all these properties present. Let's just go over some of them. For example, the reflexive property. It says that a quantity is equal to itself. AB is equal to AB, as simple as that. The transitive property. It says if two quantities are equal to the same quantity, then they are equal to each other. In other words, if A is equal to B and B is equal to C, then A is equal to C. Or, if you want to look at it, let's go over here a little closer. That's it, that's as close as I'm going to get. All right, if AB is equal to BC and BC is equally measured to EF, then AB, you see, you skip the BC and you say AB is congruent to, equally measured to EF or congruent to EF. Then we have the symmetric property. What does it say? If a quantity is equal to a second quantity and the second quantity is equal to the, if a quantity is equal to a second quantity, then the second quantity is equal to the first. If OA is equal to AB, then AB is equal to OA. Now, these are simple properties, but you need to remember the names of them. Symmetric. Okay, the other one is the addition postulate or addition property of equality. If equal quantities are added to equal, then the sum is equal. The sums are equal. So, an example, okay, if AB is equal to DF, sorry, so I'm putting here. I caught you. Oh yeah. Okay. If AB is equal to DF and BC is equal to CD, right? Then if I add BC to AB and CD to DF, then I will have the same on both sides. Let's try it with numbers. Let's say if AB is 4, so this is 4, right? And let's say this is 3. Okay, so if AB plus BC, that will be 7. That should be the same thing as DF plus CD. I hope I make myself understood. It's very simple. Okay, subtraction property of equality. The same thing. If equal quantities are subtracted from equal quantities, then the difference, which is the result of the subtraction, are equal. Okay, and the example is the same thing. You could use the same thing. So let's see now. You know what? Let's go over the example. If AB plus BC equals to CD plus DE, if we subtract, okay, if we subtract CD, okay, and let's see, AB plus BC equals to CD plus DE, then BC equals DE, then BC equals to DE, and AB equals to CD. In other words, here BC equals to DE, BC equals to DE. Since AB, okay, are equal in quantities, then if I subtract AB and CD, then I get this. Let's do it with numbers. 4, 3, 4, 3. Okay, so this is 7 and this is 7. Therefore BC equals DE. You see, 3 equals 3 if I subtract this, and vice versa. AB equals to CD, AB equals to CD if I subtract the 3. So that's what it is. Hopefully you understood. If not, anyway, in classroom I'll explain it again. Multiplication property of equality. If equal quantities are multiplied by equal quantities, then the products are equal. Okay, so just look at it. If two angles are the same and I double the angles, then the measures are going to be the same. Duh. Okay, division property of equality, same thing. And then the substitution property of equality. Okay, the substitution, it says that a quantity may be substituted by its equal. What the hell does that mean? Well, this is also like the transitive property. Watch this. If DE plus CD equals CE, okay, and CD equals AB, and CD equals AB. So then I could say that DE plus AB equals CE. A quantity may be substituted by its equal. And then we have the partition property. It says that a whole is equal to the sum of its parts. If you have an angle of 72, remember, an angle of 72 from the previous lesson, okay, and then you draw the auxiliary line that divides the angle into two different angles, okay, into two angles. Let's say into two angles. They can be congruent or different, but it divides it into two angles. In other words, if you have an angle like this, right, and you draw an auxiliary line right here, now you got this angle and this angle. That's the partition property, okay? The whole angle is equal to the sum of its parts. Beautiful. Let's start lesson, well, in this case 15. And it says unknown angle proofs of known facts. So we're gonna be proving things, but first we gotta have some facts. So remember, once a theorem has been proven, it can be added to our list of known facts and used in proofs of other theorems. Okay? And let's go over this. Let's go over this diagram right here. Forget about this writing. That's why I put the thing. I wrote it on the wrong place. So it says here in the diagram to the right, if you are given that AB is parallel to CD, how can you use your knowledge of vertical angles and alternate interior angles to prove that X equals W in measure, right? Okay, so let's take a look at the diagram first. So I need to prove that X, this angle, is equal to W. They want me to prove that corresponding angles are congruent. These are corresponding angles. Okay, but let's pretend we don't know. Let's pretend that we're gonna, gather all the facts and we're gonna put them in a bag and now we're gonna carry it around. So the first thing I would do is they are telling me to use my knowledge of vertical and alternate interior angles. Sure, I know that this angle is congruent to this one. Yes, I know, but at the end, that's our proof. So let's start. First, I'm gonna say that W is congruent to Z. Okay, because that's the one I'm using. Remember, I'm going in this direction. Okay, so W is equal to Z. Now, what is the reason? That vertical angles are congruent. Yes, so my statement is W is equally measured to C, to angle Z. And then I could say that Z is equal in measure to X. And what can prove that? Okay, that's my statement. What would be my reason? Well, my reason would be that alternate interior angles are congruent. Okay? And then since W equals Z, right? And X equals Z, then I could say that substituting the Z with either X or W, I could say that X is congruent to W. Okay, so by what? By substitution. So there you go. Copy it down. That's the proof right there. Those are the reasons. These are the statements and these are the reasons. You pause it, you copy it, and let's move on because let's make this a short lesson. All right then. So now we have available, what do we have available? What do we have in our bag now? We have vertical angles are equal in measure. We have alternate interior angles are equal in measure. And now we just added corresponding angles are equal in measure. Nice. And we already knew this. So now let's move on to the next part of our data gathering. Okay. So let's see. I need... Oh, no, not that. Huh? They kill me. Yeah, let me use this envelope right here. Okay. So let me see now. Gosh. Okay. So this is what I have. I have given segment AB is parallel to segment CD. and is cut by a transversal EF. You see how they write it? They want me to prove that angle BGH plus angle DHG equals 180. Okay, so let's go to our diagram right here. Okay, so this is what they want me to prove. They want me to prove that this angle right here, okay, BGH, B, remember, follow the path, BGH, okay, it's congruent. You see, drawing it, it helps you a lot. Creating a visual helps you a lot. So this angle plus angle DHG, okay, equal 180. So the sum of these angles equals 180. Well, from previous lessons, you already know that same side interior angles are supplementary. So yes, but this time we don't have it in the bag. So we have to prove it, and then we add it into our bag of facts. All right then. So we're gonna construct a 2-column proof. Okay, remember to do this. Okay, so now you have it. I'm gonna move on to the proof that you need to copy, but first try to understand it. The first thing I write in my proof is that the given statement, okay, is that AB, segment AB is parallel to segment CD. Given, remember, statements and reasons. Okay then. So now, let's see. I write that angle BGH, okay, plus angle AGH equals 180. Let's go over here and see what I wrote. Okay, I wrote that angle BGH, okay, let me choose a different color now. Okay, blacker. All right, so angle BGH, so this angle, I'm saying that this angle right here, okay, plus angle AGH, plus angle AGH, plus this angle right here is 180. Okay? Now you know what this is. This is a linear pair. And of course, this angle plus this angle has to be 180. But where I'm going with this? Well, I'm trying to follow a very logical sequence of steps. So, then from here, I am going to say, okay, so this is what I wrote. Linear pairs form supplementary angles. I know LP, but we will all know that LP means linear pairs, but on the test or on the regions, please don't write that, just write linear pairs, because the people kind of like, I'm not gonna say the word, but they don't know. All right, then I'm gonna move on and say angle AGH equals in measure to angle DHG. Okay, so let's go again. So angle AGH, okay, this angle is equally measured to DHG, to DHE or DHG. They're equal in measure. So now I'm gonna have to do like an orange thingy here, orange thingy here. And why are they equal in measure? Well, you know. So what I wrote was that they are equal in measure. And what is my justification? Well, if parallel lines are cut by a transversal, okay, then alternate interior angles are equal in measure. And of course, that was in our bag of tricks, right? Of facts, yes. Okay then. So now watch what happened. What was I supposed to prove? That this angle and this angle added to 180. Well, I already, look at this. This angle plus this angle equals 180. So, oh my God, I'm talking nonsense. Okay, sorry. Look at this. This angle plus this angle equals 180. And this angle are equal in measure. And because of the alternate interior property, then I could definitely say that this angle and this angle add up to 180. How? Well, substitute this angle with this one because they're equal in measure. Remember, you may substitute equals but with equals. So then there you have it. That's your proof. Please memorize how to do these proofs, how to conduct it. All right? And always create a visual if you don't have it. Okay, let's move on. You pause it, you copy. Let's move on. I don't know who's making all that noise in the chicken, in the kitchen. But it's okay. All right. So here it says use any of these 4 facts to prove that. Let me just make it smaller. I'm sorry. You should be able to read it. Okay. Gosh. Okay. Here we go. Use any of the 4 facts to prove that the 3 angles of a triangle sum to 180. Okay. For this proof, you will need to draw an auxiliary line parallel to the one of the triangle. Sorry, to the one of the triangle sides, and passing through the vertex opposite that side. Add any necessary labels and write your proof. All right, no problem. So what I'm going to do is I am going to draw an auxiliary line. If I had a ruler, I just had a ruler over here. Oh, okay. Now where to draw my auxiliary line? Let's say. Okay, okay. So I'm gonna draw an auxiliary line JK, so it is parallel to that. So I'm gonna try my best. Yeah, they kind of look parallel, yes? Okay, so this is gonna be my line JK. Okay. So let's see how do I prove that the sum of the angles of a triangle equals 180 degrees. So what are the facts? Well, the facts are that JK is parallel to BC. Okay, that's the first thing I'm gonna write. Now that was not really given. They never gave me anything, but this is always how you're going to follow this. So look at my statement. I draw an auxiliary line, okay? Sorry, JK is parallel to BC. I said it. I drew it, and it's parallel. So what can actually be a reason for that? Well, I constructed it, right? So then they parallel because of construction. Okay then. Now I'm gonna say the following. Okay? That, let me see, where is the I don't remember. Please tell me I'm on the right. A, B, C, A, D. Okay, where is D? Where is point D? That's interesting. Let me find out where point D is. Ta-dum, ta-dum, ta-dum. Point D. Let's see now. That's the only point I need. I need point D. D. I don't know. My God. Point D. Point D. Oh my God. Of course. Yeah. And now I cannot find my pencil. Where's my pencil? Oh my God. Seriously, what did I do with the pen? Oh, I couldn't find it because it's Spider-Man. Okay. So what I'm going to do is the following. I am going to call this angle D, and I'm going to call this angle E. Okay? Yes? All right, perfect then. So now, and don't ever forget that. So now I have this, And what can I do? Guys, I think I know. Let us just forget a little bit of the proof that we gotta write and let's focus in here. So this is angle A, correct? It's called angle A. This is gonna be angle B. This is gonna be angle C, correct? Yes, okay. So DAE are consecutive angles on a line, right? Or angles on a line, however you want to look at it. So I know that these angles are supplementary. These angles are supplementary. Oh, okay, so I could write that. All right. Now, what are you talking about? Oh my God. Okay, if this is 180, right? Then I can say that D is equal to B. Now, bear with me just a little bit. This is equal to 180, right? I could say also that D is equal in measure to B. And I think you know why. Okay, and I can say that E is also congruent or equal in measure to C. And I think you know why. Yeah, you know why, you know why. Lines parallel, transversal, interior, huh? Yes. Okay then, so I can substitute these quantities with these quantities. And this is 180 together with A. So therefore, these are also 180 since these two angles are equal in measure to these two angles. Beautiful. Okay, so then now let's start writing our proof. Focus, 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 focus. Okay then. So that's what I wrote. DAE equal to 180. Why? Because, and look, I number the statements and I number the reasons because sometimes the reason might be very, very long and it might not line up with the statement. So angles on a line sum to 180. That was for number 2. Then number 3, I decided that if parallel lines are cut by a transversal, then alternate interior angles are equal in measure. Ah, okay. And again, the same reason for this one, because I got this one and this one right here, alternate interior. So the same reason goes for that. And then guess what? I can substitute DE, okay, DE with BC. And that's why the angles in a triangle sum to 180. All right, so you got your proof right there. And now let's move on because you just pause it and copy. Okay. Let us go on to another one of the proof. All right, so let's see. What we have so far are the following. We got vertical angles. We got a transversal intersects a pair of lines. The pair of lines is parallel if and only if, right? Alternate interior angles are congruent in measure. Corresponding angles are congruent in measure. Interior angles on the same side of the transversal add up to 180. The sum of the degree measure of a triangle is 180. So we have proven those, and those we have in the bag. So we're gonna be using all those in order to continue with our proofs. We're almost done. We only have like 6 pages left, so don't worry about it. All right, so let's move on to the next one. Now here it's a little bit tricky because you are asked to draw a diagram. Okay, well, you're not really asked to draw a diagram, but or maybe yes. So it says construct a proof designed to demonstrate the following. So you're going to demonstrate the following. If two lines are perpendicular to the same line, they are equal to each other. Is that, no, I read it wrong. Sorry, I'm reading from the camera. Let me read it on the paper. If two lines are perpendicular to the same line, okay, they are parallel to each other. Oh, got it. All right, so if two lines are perpendicular to the same line, they're parallel to each other, okay. Now draw and label a diagram. I did. I labeled it, and so should you. State the given facts and the conjectures, conclusions, okay? Conjectures are conclusions. The given facts and conjectures to be proved. And finally, write out a clear statement of your reasoning to justify each step. All right. So they just told us that if the lines are perpendicular, two lines are perpendicular to the same line, they're parallel to each other. So let's see. We have the diagram. So this is what we need to prove. It says if AB is perpendicular to EF and CD is perpendicular to the same line, then prove that AB is parallel to CD. Okay, you think that's difficult? Let's try it. So we have the measure of AGH. AGH. And what do we know? It's 90 degrees. The measure of CHF is also 90 degrees. Okay? Wait, but how do I know that? Hello, in the given, they told us that AB is perpendicular to EF. You see that? Just with that fact, just with that knowledge, boom, we know that they measure 90 degrees. So we label them. And what is my reasoning for this? Well, perpendicular lines form 90-degree angles, correct? Or if you want to, in the future, you don't have to write all that. You could just say definition of perpendicular lines. And everybody understands that. Okay. So that's it. Now, what? I don't get it. I'm supposed to prove that they're parallel. So how do I do this? Well, look at the second statement. Okay, it says measure of AGH equals the measure of CHF. It says transitive property of equality. Since measure of AGH is 90 and measure of CHF is 90, right? Then it's transitive property. In other words, and also let me tell you something. You could have actually used substitution property of equality, because AGH equals 90 and CHF is equal to 90. You could substitute that 90, okay? Or you know what? Even so, now let's leave it as substitution. Okay, so now we use the transitive property. And last but not least, okay? It says that I have proven that B is parallel to CD. How? How did I prove that? I know that these angles are equal in measure. Okay, they both 90, therefore they're equal in measure. So okay, transitive property. Oh my God! If they are equal in measure, that means that they're corresponding angles. That, of course. So then, AB is parallel to CD, and my justification is that if two lines are cut by a transversal, and a pair of corresponding angles are equal in measure, then the lines are parallel. Beautiful, beautiful. So I'm gonna leave the whole thing here. Let me take this tape out. So we go here so you could see the whole thing. There you go. You pause it, and then we'll move on. All right, so let me go on to the next proof. All right, what is the converse of something? The converse is just to say the same thing but in reverse order, okay? For example, and these are things that you need to have in mind in order, because sometimes you need to go backwards and sometimes you just go with the flow. So it says, these are original statements, okay? So the original statements. If two parallel lines are cut by a transversal, then alternate interior angles are equal in measure. The converse of that, if two lines are cut by a transversal such that alternate interior angles are equal in measures, then the lines are parallel. Okay? So here is if two parallel lines are cut by a transversal, then we have the alternate interior angles equal. Here is like if the alternate interior angles are equal, then the lines are parallel. You understand that? If I go to school, then I wake up early. The converse of that is if I wake up early, then I go to school. Right? Okay. And the next one is if two parallel lines are cut by a transversal, then corresponding angles are equal in measure. If corresponding angles are equal in measure, then the lines are parallel. If two parallel lines are cut by a transversal, then interior angles on the same side add to 180. So guess what the converse will be? If the two interior sides of two lines cut by a transversal add up to 180, then the lines are parallel. Okay, these are facts that prove lines parallel. All right, just copy this. It's not much. Okay, it just says to prove that. Okay, we got x equal to y. Okay, and to prove that the lines that AB is parallel to EF, you already know that these are basically corresponding angles. So then that's it. Okay. Okay, now you could pause it and let's move on. Okay, this one is kind of different, but still the same thing. All right, so what I have is that I need to prove that AB is congruent to CD, right? Okay, and how am I gonna prove that? Well, they gotta give me some type of information, right? So it says that given that C and D are supplementary and B and D, what? Given that C and D, angle C and angle D are supplementary. Oh, okay. Angle C and angle D are supplementary. Okay. So, and then it says an angle B. Oh, an angle B equals angle D. Oh, I get it. An angle B equals angle D. An angle B. Okay. So this is congruent to, sorry, angle B is congruent to angle D. My bad, not this one. Not this one. Angle B is congruent to angle D. So you do hash marks to note that they are congruent. Well, and when you see it, it's obvious. All right. So this is what we know. So let us start writing our proof. So the first thing I'm gonna say is that these two angles are supplementary. Why? Well, not because they are angles on the same side of the transversal. No, it was given to us. See that? It was given to us. So that's what I write. That angle C and angle D are supplementary. Why? Given. Okay. Now, they're supplementary. What does that mean? Okay, that means that they add up to 180 degrees. Oh, okay, so then that should be your second step. Okay, not always you're gonna skip. So then we're gonna say that measure of angle C plus measure of angle D equals 180. Now, why am I writing this? Because I need the reader to know that they equal 180 because I'm about to do substitution. I'm about to maybe substitute angle D with angle B. Maybe, I don't know. All right, so let's see now. What am I writing? That angle B is equal to angle D. But what is my justification? Well, that it was given to me. Now, of course, it was given to me. I could have written it as a second statement if I wanted to, okay? It really doesn't matter as long as you justify as you go. So it was given to me. Now, why am I taking so long to write the given? Well, look at this. Measure of angle C plus measure of angle B equals 180. Oh, wait. Measure of angle C plus measure of angle B equals 180. And I told you that we were going to substitute something. See that? Okay. Now, number 5. AB is parallel to CD. Now, did I really prove that they are parallel? Well, look at the justification. If two lines are cut by a transversal such that a pair of interior angles on the same side are supplementary, then the lines are parallel. Okay, so interior angles. Okay, what if I was to, let us just draw this right here. So my diagram, I could extend the lines in my diagram so you could actually see where I come from. Okay, and now these transversals need to be longer. Okay, so these lines right here, okay, these lines right here and these lines right here, they create actually angles on the same side of the transversal. These two lines right here, okay, that's what we needed to prove, that they are parallel. So all you gotta look at it is at the two lines and these being the transversal. Okay, they're on the same side of this transversal. You could look at it this way if you want to. The two lines and these are in interior angles on the same side of the transversal, and that's why it's 180, and that's why they are perpendicular. All right, so here I have to prove a theorem. It says, prove this theorem. Construct and label an appropriate figure. State the given information and the theorem to be proven. List the necessary steps to demonstrate the proof. So it says, given segment AB parallel to CD, okay, and EF perpendicular to AB, EF intersects CD. Prove that EF is equal to CD. So then what you're going to do is you're going to create your diagram. So how would you create your diagram? I need to know. Create your diagram. Yeah, kind of tough, right? Well, I need you to do it. I need to drink some water while you do it. Okay, any luck? Let's see. It sounds like something we did before. So let's see, I have AB parallel to CD. Sure. How do I want to do this? I could put AB right here and CD right here and they parallel. Or I could do it like that. You know what? Just for the sake of, always contradicting everything, I want to create the two lines parallel right here. Just for the sake of doing it and doing it. So this is gonna be AB and this is gonna be CD. Okay, and now it says that EF is perpendicular to AB. That EF is perpendicular to AB and EF intersects CD. Okay, whatever. So it's perpendicular, so I'm gonna try to make it as perpendicular as possible, okay? I hope that's perpendicular enough. So that is basically EF. Oh, okay. Now what? No, that's it. All right, so I have a problem. Every time we do a diagram, I have a problem. We have this point right here. So this point has to have some type of name. So these are lines, okay, but these points kind of like are angles. So let us call this angle, what do you want to call it? Let's call it G, and let's call this one H. And we already know what they are. We already know that they're right angles because they're perpendicular, okay? So we already know what happens. We already have that facts in the bag. So let's conduct the proof. I'm supposed to prove that EF is perpendicular to CD. I'm supposed to prove that EF is perpendicular to CD. We know it's perpendicular to AB. So let us start. And what do we start with? Always the statements, okay? Statements and reasons. And my first thing is going to be the given, okay? AB is parallel to CD. They said it. And I know that EF is perpendicular to AB. Boom, given. Now, from that, what can I conclude? Well, I can say, and let me just make this a lot bigger. Okay, like that, hopefully. Okay, so I can say that angle BGH, okay, BGH measures 90. Yes? Okay. Now, what else can I say? Well, these two lines are parallel. Hello, these two lines are parallel. So if they're really parallel, then this angle should be congruent or equally measured to this angle due to corresponding angles, correct? They're already parallel. You don't have to prove that they're parallel. Oh, son, you're nice. Of course I'm nice. Okay, so then that's what we do. We write that angle BGH, okay, BGH is congruent or equally measured to angle DHF, okay? Therefore, thus concluding that my proof, EF is perpendicular to segment or line CD. That's it. And wow. That's it. That's the end of your packet. Voila. Bye-bye, packet. See you on YouTube. Oh, wait.